So welcome to the coffee lecture number 12 from the Chemistry, Biology, Pharmacy Information Center. The topic today are NIST chemistry databases. My name is Jozica Dolenc. I'm a chemistry information consultant here in this unit, and I'm going to show you a couple of those databases in this 10 minutes. Now, NIST is the US National Standard of Institute of Standards and Technology, and they provide access to really many physical and chemical property data through free databases and also fee-based databases as a part of this NIST standard reference program, which is called SRD. And what is really interesting is that this SRD program has been mandated to NIST by the Congress in 1968, so many years ago, with the goal to make data, chemical and physical data, open and available to scientists and general public. And that's a big topic nowadays also with open data, but it's been a big topic back then already. If you go to the website, www.nist.gov and then SRD, you will end up on the web page with this standard reference data catalog, where you can then scroll through all those databases and check which of them are of interest to you. And you can see on the left-hand side here, you can just check for free reference databases. Also, if you don't have any funds to pay that, or else let us know if there's a database that you find really, really important for your work. Library has a certain budget for smaller things, and we can then have a look into that. Now, the most popular chemistry databases, which we are working here in chemistry, are the NIST Chemistry Webbook, UPAC NIST Solubility Database. Both of those two are free. And then it's phase equilibrium diagrams online, which is actually fee-based and is licensed by the ETH library. And I'm going to quickly show you what that is. And then we have NIST JANAV thermochemical tables, which has been recently used in the physical practicum here with us to calculate heats of reaction. And then another very important, also for material sciences, is NIST Inorganic Crystal Structure Database. It's also fee-based and it's licensed by the ETH. So this last one, I will not have time to present today, but I presented it in a special coffee lecture some time ago. So if you go on the YouTube channel of the InfoCentrum, you will get our past coffee lectures. And then if there's a coffee lecture you would like me to repeat or us to repeat, let us know. Yeah. Okay, so let me go on. NIST Chemistry Webbook is very, very known among chemists because it's free and it contains thermochemistry data, spectroscopy data, data on ion energetics if you do MS, chromatography data, and also links to other NIST databases. And I'm just very quickly going to demonstrate you how this looks like. So I'm going to open browser. Yep, let me make that a bit bigger. Sorry, so that's prepared. And I have a link up here already. So this is NIST Chemistry Webbook. And if you need to search for a molecule, you can search in many different ways. I will now just do a very simple search for one for dioxane. And just to show you how then the entry looks like. So this is now the result. And you can see first it's like all kinds of information about the molecule, and then comes the data. And the data is down here. So if you're interested in gas phase thermochemistry data, you have here heats of formations, constant pressure, heat capacity of gas, and so on. And you always see at the end who has compiled the data. So the data in those databases is really evaluated data. It's not data that has been extracted by AI from papers. Yeah. So this is, people have looked at those data. Now, similar things, phase change data, if you need, boiling temperatures and so on, triple temperatures, you have all that here, enthalpies of vaporization. It's under that category. Reaction thermochemistry data for some reactions of dioxane. I have to say, this part of the database is not very big, so don't expect to get complex reactions here with thermochemistry. We will not get that, but you can always check what's there. Then we have Henry's law data. So if you need Henry's law constants for solubilities are listed here. And then we have what is also important. I don't know if somebody's doing mass spectroscopy, we have gas phase ion energetics data, really a lot for this molecule. And then we have ion clustering data. These are then reactions again, and then our spectra. So we have spectra here of gas and in solution. And if you click on that, you get the spectra. And in case you need it sometimes, this is a database where you can also download the spectra. Now I can't see it here. Yeah, so if you need sometimes to play with spectral formats or to check how they look like, you can download them from NIST chemistry webbook, UVBIS also, and so on. And then the last thing I will mention with respect to this database is this gas chromatography. So if you ever need to do GC, there's a lot of information on Kovacs retention indexes here for different columns and different conditions. So you get those values for different phases in that database too. These informations are sometimes a bit more difficult to get, and so that's why I show you that. So that's all about chemistry workbook. Now I'm going to just quickly show you the second database. It's a solubility, NIST UPAC solubility database. And this is actually a database which is pretty old, and it's based on this UPAC series, a UPAC solubility data series. We have the books also in the library. So, but here you could look through the volumes. Now, it's not the idea that we browse PDFs here, but we go for search. So if you have a molecule that you would like to check solubility of, you can just go here, let's say one system component, and let me now put in the CAS registry number of the dioxane, just to do a different type of search. I could also put the name here. And if I submit that, I will see what kind of data on solubility of the dioxane is in this database. So you see, this is the molecule I was looking at before in this chemistry database. And here now I have solubilities with all these molecules available. Now, if I click on, for example, on biphenyl with 1,4-oxane, what I get is the solubility at different temperatures for those mixtures. Yeah, so you have mole fraction of component 1, mole fraction of component 2, and the reference where this comes from. That this one is pretty old, but it doesn't matter, right? I mean, if it's good, you can still look into this data. And then below, it's a very small, short description how this has been measured. So this kind of data are in the solubility database. So these two are free databases. And now I promised the phase equilibria diagrams online. So this is a database which has been licensed by the ETH. So you see here, welcome ETH Bibliothek, because they are paying for it. You need to be within the ETH network to use it. And it's very easy. I have a very simple example here. But here you can basically search by chemical system or by publication. And you can see here different options to search by components or elements. There are always more information you can look at. I will now just put platinum as an example. And I could go here for other components list if I would want to. You can use periodic system, and I could say which elements should not be there. Since I don't have so much time, I will now just make a search, and then you will see what you get. So I got now results here, 29 results of different chemical systems that contain platinum. And since it's a database on phase diagrams, that's the most important part. So if I click now on this PET figure number, I see the phase diagram here on the right-hand side. And if I click on it, then an interactive phase diagram opens for this now very complicated system. So I can go inside and check where I am. I can select the nearest curve to where I am. I can do all kinds of things. I can swap components. You can also download the diagrams at the end. So if you need to search for phase diagrams, I think this database is very important. The other database, which is very important and which I gave the coffee lecture on recently, is Springer Materials. So for material scientists here in the room, please have a look at the Springer Materials coffee lecture on our YouTube channel. Okay, so that's all what I wanted to say about phase equilibrium online. And now the last one, NIST Janov database. It's also a very interesting one if you need to search for thermochemistry of reactions. I hope it will open. Or it doesn't want to open from here. So let me go again. Yeah. So that's that one. It's also a very old database, and it has actually been made for rocket scientists. And I figured out that JANAF stands for Joint Army Navy Air Force. Because yeah, they needed access to thermodynamic data for the Air Force. Yeah, so here what you can do, you can search for element and their compounds, elements and their compounds to find standard heat formation and heat capacity. So it's about thermodynamics again. So I'm just gonna take now hydrogen peroxide as an example. So if you click on that, what you then get, it's a very simple page, but the information is there. So you see the temperature dependence of heat capacity of hydrogen peroxide, and then we have also entropies here and the free energy function. And then the part which is most used in my opinion and in my experience here are the standard heats of formation for hydrogen peroxide at different temperatures and the logarithm of the constant of formation. Yeah, and these data you can then also download and work with it. So sometimes students ask me for this kind of data because you have all kinds of exercises that you need to do in thermodynamics, and then you want to check if you've calculated the properties correctly. So that is one way also to get to the data and see if you're completely off with your experiment or not. All right. And with that, I'm already at the end. It's a short 10-minute coffee lecture, and I would like to tell you that I've prepared a digital coffee lecture card for this coffee lecture. And if you like it, if you want to have it somewhere saved for the future, just go to this email, to this link, and you can download it then with the basic information. And you will remember maybe for the future that this exists. And once again, there are many, many more databases under this SRD program, and I hope they will stay. So have a look at what is interesting for you. I was focused today on the chemistry. And now with that, I will go already towards the end. I'd like to thank you for your attention. It's really nice you're here on that very nice sunny day outside. I was wondering if somebody comes. And would like to invite you to our next coffee lecture next Tuesday, which is actually a very, very important topic once one starts to publish, to know about copyright and where you can publish and for how much money, to make your articles and open access so that the whole world can read them. And there are many, many tricks around that. And Oliver Wren will explain it in 10 minutes. So thank you again for your attention and hope to see you again. And I'm open for questions.